Morning. It's like 6:30 in the morning, and I'm gonna try and do a presentation on today's activity, um, so that it's easier for you guys to get it done, um, and for those that need extra help. So I'm doing this sight unseen, right? You can tell how early in the morning it is because the light wasn't even on yet. So let's take a look. Let me share my screen, and let's go with it. Sorry for taking a little bit. There you go. All right, I got to do this relatively quiet because everybody's still asleep. So for those of you that need to increase your volume, I totally understand. Okay. All right. So this is the original. Let's take a look. And so for whatever reason, I had the the thing set in that it would show my last name and stuff like that. But for whatever reason, it's not doing that anymore. Hey, look at that. I don't know what this is, but I'm going to figure that out because that looks pretty cool. I don't know what that was. All right. So let's go to the next one. Oh, oops. Let me see. Let me go back. Previous lesson, you saw that heating the reactants increased the rate of reaction. You learned that the heating increases the speed of the molecules and that the fast-moving molecules hit each other harder and more often. These two factors enable more molecules to react, which increases the rate of the reaction. So by heating it up, you can make it go faster. In this lesson, you'll investigate another way to increase the rate of a chemical reaction. In this method, another substance called a catalyst is used. You'll look at models of the atoms and molecules in the reaction to get a better idea of how a catalyst uh, works to make a reaction happen faster. So basically, you're going to have A plus B equals C, but what you're going to do is you're going to take A plus B plus D equals C quicker. All right, somehow. All right. Elephant toothpaste, one of my favorite reactions. One of my favorite reactions. You mix uh, hydrogen peroxide and some dish detergent, and, and you mix some stuff up in it, and it gets a massive explosion. It's really cool. So let's take a look.
This is a wonderful demonstration of the effects of a catalyst. It's known as elephant's toothpaste. While there are no elephants or actual toothpaste involved, it will look like we're forming toothpaste. In the bottle, we have hydrogen peroxide. Hydrogen peroxide decomposes and breaks down slowly into water and oxygen gas. We can speed up this reaction by adding a catalyst now. The catalyst that's being added is not a reactant, and it's not a product. All of the reactants were actually in the bottle to begin with. It was the hydrogen peroxide. The catalyst that is added enables the hydrogen peroxide to decompose and break down faster, and so the reaction becomes very noticeable. Also in the bottle at the start was a little bit of soap. What's happening is that as the hydrogen peroxide decomposes and forms oxygen gas, the oxygen gas bubbles are getting trapped in the soap and making a foam. Finally, there were stripes of green food coloring along the side of the bottle. This was to make it look more like classic toothpaste, but it's certainly not part of the chemical reaction. The catalyst allows this reaction to happen a lot faster. With a higher reaction rate, products are being formed quickly and are a lot more noticeable and exciting to watch.
So the reaction was going to take place regardless if the stuff was put in there, but it just sped it up. So in the video, molecules of hydrogen peroxide react with each other to produce water vapor and oxygen gas. Also, a detergent solution and food coloring were added to the hydrogen peroxide to make it more fun to watch. Normally, the reaction between hydrogen peroxide molecules happens slowly, but in this demonstration, a substance called a catalyst is added to mask the reaction happening much faster. The catalyst makes the reaction happen faster, but does not become part of the products of the reaction. How can you tell that a gas is produced in the chemical reaction? The vapors coming off the top. Pick one word that completes both of these sentences. The lesson is about speeding up reactions. Some reactions occur very slowly, but chemicals called catalysts can be added in order to make them happen faster. The elephant's toothpaste demonstration relies on catalysts. Yes. Which statement is true? A catalyst is considered a reactant or a product. Neither. It's neither of those. It's just added to it. The foaming and the thing means that gas is coming off the top. Yeah. Oh, okay. All right. I saw the vapors coming off the top. But yeah, the foaming definitely definitely shows that a gas is produced because it's increasing the volume going out. Yeah. Okay. Count them all. All right, here's the chemical reaction for the reaction, chemical equation for the reaction in elephant's toothpaste demonstration. Two reactants are two hydrogen peroxide molecules, and the hydrogen peroxide has the chemical formula H2O2. When two hydrogen peroxide molecules react with each other, two molecules of water and one molecule of oxygen are produced. The reaction gets warmer and is also exothermic. It gives off energy. How many types of are in the 2 molecules of hydrogen peroxide? So there's four. 2 times 2 is 4. 2 times 2 is 4. All right. 4 and 4. How many are in the products? 2 times 2 is 4. 2 times 2 plus 2. So 4 and 4. All right. So it's even. The reactants have 2 and 2 and 2 and 2. Cool. And the products there is 2 and 2. Everything is balanced out. And notice the amount. This is the same as the products and the reactants. Okay. All right. Good. Genie in the bottle demonstration. What's her name? Christina Aguilera. Yeah, it's a good song. Let me tell you. Let's take a look.
This demonstration uses the same reaction as elephant's toothpaste, but there's no detergent. In the bottle right now, we have hydrogen peroxide. It is decomposing very slowly, and it's not very noticeable. Now we'll add a catalyst. Watch what happens as the reaction rate increases dramatically with the addition of the catalyst.
That's the vapor that I saw. I saw the itty bitty vapors coming off the top of the elephant's toothpaste.
The steam coming out of the bottle is water vapor that is condensing as it leaves the bottle. The other product is oxygen gas, which is also leaving the bottle, but it is invisible. The bottle gets very hot because the reaction is very exothermic, which means the reaction is producing a lot of heat and the water is coming off as a vapor. When that vapor cools and condenses, you can see it. The genie in the bottle demonstration is often done with a more effective catalyst or with a stronger concentration of reactants than the elephant's toothpaste version, so that you can get this interesting and exciting event without using soap bubbles.
Cool. Steam coming out of it is water vapor. It's condensing as it leaves the bottle, and the oxygen also leaves, but it's invisible. The bottle gets very hot. It's very exothermic. What are some similarities between the elephant's toothpaste and genie in the bottle? They both have water vapor and oxygen gas, as products, and both exothermic or give off a lot of heat, give off heat. What are the differences? Hydrogen peroxide or elephant's toothpaste paste expands as a foam, and the genie lets off steam. Okay. All right. Both of them demonstrate chemistry breaks down in water vapor and oxygen. Right. All right. And this one is presented is added foam. So this is a foam, and this one is steam. Yes. They also use different catalysts. Nut. Forgot that one. We're studying about the decomposition of hydrogen peroxide when a catalyst is present. Notice how the catalyst does not appear anywhere in the chemical equation. That is because the catalyst is neither a reactant nor is a product in the reaction. All right. So different types of catalysts in both of them. Now let's take a look at the third one called yeast. Right? Not yeast. Yeast. Get it? All right. It is actually produced as part of the hydrogen peroxide is produced, but hydrogen peroxide is bad for yeast. So yeast has a catalyst in their cells to destroy it. This catalyst speeds up the reaction between hydrogen peroxide so they become harmless water and oxygen. If you add yeast to hydrogen peroxide, we can see this catalyst to speed up our reaction. All right, so let's take a look.
We've been studying the decomposition of hydrogen peroxide in the presence of a catalyst. So far, we've seen two different catalysts aid the same reaction during the elephant's toothpaste and genie in a bottle demonstrations. Now we're going to look at a third catalyst, which is yeast. You may have used yeast while baking, but did you know that yeast are actually alive? Yeast are a type of single-celled fungus. We add them to bread dough because they ferment, or eat, some of the sugars in the dough and produce carbon dioxide gas. The gas that's produced makes the dough expand, and the resulting bread is lighter and softer. Let's put bread making aside for a minute and think about another use for yeast, as a catalyst in the decomposition of hydrogen peroxide. Hydrogen peroxide is actually produced as part of the chemical reactions that naturally occur inside a yeast cell. But hydrogen peroxide is bad for the yeast, so yeast have a catalyst in their cells that help break it down. This catalyst speeds up the reaction between hydrogen peroxide molecules so they become harmless water and oxygen. If we add yeast to hydrogen peroxide, we can use this catalyst to speed up our reaction. In the following video, yeast will be added to a hydrogen peroxide solution. You can see that on the right. Most of the molecules in the hydrogen peroxide solution are water, with some hydrogen peroxide molecules mixed in. We'll see how the yeast catalyzes the breakdown of the hydrogen peroxide. In this video, the same amount of yeast is also added to water on the left to make sure that the reaction we observe is truly caused by the breakdown of hydrogen peroxide and not caused by the way yeast acts in water. All the substances are at the same temperature. Both the water and the hydrogen peroxide each have 1 drop of detergent solution added to them. The hydrogen peroxide is breaking down because yeast is acting as a catalyst. Water and oxygen gas are produced. The oxygen gas forms foamy bubbles. Compare this to the graduated cylinder on the left. It is clear that yeast does not catalyze any reaction between water molecules.
It's pretty cool. So the chemical reaction occurred in the video. Foamy bubbles. What is reactant in this one? Yeast. What is a catalyst? No. What is a reactant? Hydrogen gas? Oxygen? So water, hydrogen peroxide was created No, oxygen was created. That was the product. Hydrogen peroxide was the reactant. What was the catalyst? Yeast. All right, I had to think about that one for a second. When you write the equation for this, should yeast be in the product side? No, no. It's used up in the um, in the process, and water and water vapor and oxygen are the products. I had a brain fart for a second. I had to think about it. You said a chemical reaction is taking place from the bubbles. Yep. The reaction is hydrogen oxide, the catalyst thing, the products are all right, cool. It took me a second to think about it because all right. When you write the equation, yeast is not listed on the product side. The catalyst is yeast, right? Yeah, but it's neither included in the reactants or the products. No, it's used up. It's gone. Right. So good. Yeah. So that's it. A catalyst is a substance that can help. I think it's a catalyst that can help the reactants in a chemical reaction react faster. I think of one of the demonstrations or experiments and the thing that you have found very memorable. Explain how this demonstration or experiment helped you understand one of the key concepts above. Um, yeah, the elephant's toothpaste. I used the uh, used the catalyst. You spell catalyst. Catalyst to make it go faster. It would have gone. It would have uh, uh, occurred. The experiment would have occurred, but it wouldn't have occurred as fast. How do I feel about this? I'm good. I have a couple questions, obviously, because I had that brain fart. But a copy of your emails will be, copy of your responses will be emailed to a Ricardo. Uh oh, I don't want a copy sent to me. I gotta fix that. Hold on a sec. I do not want a copy sent to me. Hopefully, I can get one back. All right. So yeah, I'm not gonna have some coffee. This was only about a 15-minute video. So yeah, hopefully this helps you guys out. And I gotta fix that because I don't want a copy. I want you to have the copy, not me to have the copy. All right, so let's see how that goes. All right, and we'll see how the experiments are. Elephant toothpaste, a lot of fun, a lot of fun. But if you get a chance, look for Devil's toothpaste. Totally explosive, very violent, but really cool. See you guys.